Again? Was that you yesterday? Sawyer, pass that over to me, please. All right. You blessed it?
I bless you.
What do you need? All right. So the question has been asked multiple times of, do I combine first or do I simplify first? And the answer is it really doesn't matter. I like this. Yes. So I can do either one. It doesn't matter. I can simplify them first and then combine them, or I can combine them and then simplify them. So whatever you want to do, what did y'all do? Combine them first. So on the outside, I have 3 and oh my God. Yeah. What? 30, because the number's outside. Multiply. This is a multiply problem. So 30 square root. What now? Oh my God! 18 and the 4. 36, 72. W16. I did. Then we're going to do this. That's right. What 2 numbers are you going to use?
36 and 2.
30. So why, Max?
That's the highest that you. Shut up. That's because it's the highest perfect square.
The highest perfect square. So the square root of 36 is 6. Square root 2. And then 2 goes into 16 how many times?
Wait, what?
Okay, because 36 times 2. The square root of 36 is 6, and the square root of 2 just stays in. Right, right. There's automatic, that's right. I didn't understand what you were asking. What? Whatever the root is outside. Okay, this 8 is not on the radical. It's like this. Say that again. You couldn't add them unless they're like radicals. So like radicals means that the root and the number under the radical is the same. So either one, I do. It just depends on how, if I see it right away. This, I would combine, this would be 8 times the square root of 2w because they're like radicals. Right. Oh. 16 and 3. So that gives me 8 times the 4th root of 16 is 2 times the 4th root of 3. Minus, what's the biggest perfect square I can divide 90 by? 9. So I have 9 and 10. So that's 5 times 3, square root 10. And then this is just 9 4th root 3 because 3 can't break down any. So what I have is 16 4th root 3 minus 15 square root 10 plus 9 4th root 3. But that's not all because I have 2 what? Which ones are like?
25, 4 square root 3. Minus 15.
Right.
Oh gosh.
What you got, Scott? Because she's a nice person. bursting with sarcasm.
I could have sat here silently and not helped you.
He did just say he actually really likes it. Kind of nice. Okay. Yeah.
Yeah. Okay.
3:15, wait till the bell rings. Okay, so here's what we're going to do. We're going to look at some dividing radicals, but it's not going to be anything like when we divided polynomials. It's just going to really be simplification. And here's what you have to remember. We've kind of already done this with regular square roots. It's just now that it's roots. So it's fourth roots, fifth roots. So, for example, I might have something like 36 times the fourth root of 1,250 divided by 9 times the fourth root of 2. Well, because these are the same root here and they're radicals, if I'm multiplying or I'm dividing, I can put them under the same radical or I can keep them split up, depending on whatever works best for me. Well, I know that 1250, well, I might not know 1250, but I know that 2 is not a perfect root. And I know that I can divide 1250 by 2. I also know that I can divide 36 by 9. So this is where you just have to kind of be intuitive about it and go, what can I do? Well, yeah. It would still work, yes. I will tell you, be very careful in the few quizzes that I glanced at. Don't leave your root off, okay? Because remember, if there's not a root there, what's the implied root? 2. So if you don't put the 4, your answer is completely wrong because it's not a square root, it's a fourth root, right? Oh, I went a little bit easier on you on this one for that. 36 divided, I appreciate that word. 36 divided by 9 is, of course, 4. And then contained within this fourth root, I have 1250 divided by 2. And so you might say, well, why in the world is that going to help me? But it helps me because, somebody already said it, 1250 divided by 2 is 625. What is nice about 625?
It's a perfect cube.
It's a perfect fourth. So, and it's 5, that's exactly right. So this actually simplifies to 4 times 5, which is 20. It is, isn't it?
Wait, when it is a perfect, if you don't put it in
No. Sometimes in calculus, we go through this big, long, complicated problem, and then at the end, it'll be like x equals 0. And you just go, at least give me like 2.7536 or something. I don't know. Or just write 20. All right, let's do, okay.
What if the things aren't?
Like, what if they don't go into each other kind of thing? Like, what if I have something like this? So I have to kind of decide, what am I going to do? Well, does 40 divided by 27 give you a whole number? No. I could simplify both. So just like I can put them together if I need to, I can also split them up. Why is that handy, Kylie? Why would? Because 27 is a perfect cube, right? What's the cube root of 27? 3. And what about that 40 up top? Can I do anything?
Yes.
What?
8 and 5. 8 and 5.
8 and 5. That's exactly right. What's the cube root of 8?
4.
So it's 2 cube root of 5. And now I'm completely simplified.
I like this.
You like it?
This is easier than the other one.
Okay, up top, 8 and 5. The cube root of 8 is 2. We would have to rationalize. We are not going to rationalize with anything above a square root. So don't freak out about that.
If the thing, what if it, like, if it's the first one, like with 36, but what if the exponent, the little exponent in front of the, like,
The root,
isn't the same?
then you couldn't combine them.
So then you would never just put the sum like that.
Not bigger than it will be. I'm fixing to talk about rationalizing denominator, but we only rationalize with square roots. Have we talked about conjugates in here? We've talked about conjugates, right? This is not a conjugate, but if I had to simplify this, what's the problem with this?
Can't, because they're both aren't. No
Can't have a
terms.
square root in the bottom. Now, I need to get rid of the radical that's in the bottom, but I don't need times it by itself, but what can I do before timesing it by itself? Simplify it, because if I can work with something smaller to start with, it's going to make my life easier. So what does 12 split up to? 4 and 3, right? So this is 3 root 2 plus root 6 over, what is it simplified? Say it the other way. 2 root 3. So I need to get rid of the square root of 3, right?
Yes.
I love this so much. So I'm going to multiply the top and the bottom by square root 3, right? Why do I not have to do the 2? Sorry.
Because the 2 is a whole number.
That's right. That's right. I'm only worried about what's in the house.
Nope. Push. Nope.
You could. It's not that it's wrong if you do that, but what's going to happen is you're going to have more to simplify up top. You'll have a little bit further to go with your simplification. Yeah. All right, so what happens up top? Uh-oh. I got some distributing to do. 3, why did you get root 6? The 3 and the 2 multiply together, right? So that's square root 6 plus square root of 18. Everybody's over. What's 6? 2 times square root of 9. Okay.
Well, hold up.
So if we were if I would
Square root of 3 times square root of 3. Anything times itself in a radical just gives you what you had under the radical initially. Square root of x. Some of you did this on your quiz too. You got down to square root of k squared. That's k.
Yeah.
Because the square root of k times the square root of k is k. Okay? The square root of 3 times the square root of 3 is 3. Just like the square root of 2 times square root of 2 is 2, square root of x times square root of x is x, the square root of 3 times square root of 3 is 3. Yeah. You would have had a little bit bigger numbers to
What
work
if
with.
it was the cube root of 3 squared?
Yes, yes. And it's actually going to simplify a little bit further. What? Then that doesn't. All right, so look, I'm still not done, right? What do you see that I could do?
18 and 6. You would put it in
18.
3, 6, and then
Oh,
those
no.
add together.
Oh, wrong.
That would be 3 and 6, would it not?
The square root of 18 would be 9 and 2.
And that breaks down the.
So up top, and I do need to check this, because if these are like radicals, I would need to combine them. You see how we're bringing all this stuff together now? They're not, though. They're not like radicals, so now I'm good to move on. So when you simplify them, be very careful. We did this a little bit with the quadratic formula. I can simplify, but only the numbers out front. Okay? Don't throw stuff under that radical and start working with that, because they'd all have to be under a radical simplified. But I could divide them all by 3, and so my answer would be
Whoa.
yes. So I'm going to start these going around. I'm going to work a couple more examples, though.
Wait, whoa.
It didn't do front and back, and I'm sorry. Grab 2 sheets.
Where before you go? Oh, I realize.
We probably are not doing them all. Just stay with me for just a second and I'm gonna tell you. All right. Let me show you one more example.
Mind your business. This is my partner, that's your partner. Let's keep the conversation to a minimum.
Why don't we print the prototype?
I don't know, it messed up.
I'm so glad that's. I love you, bro.
I'm not dead.
I gave the whole stack.
You're fine, I'm over here. That's how you, the next book didn't tell him he's got.
No, that's an awkward
I'm the liar.
Odds on your homework. Odds on your homework. But take 2 pages. Odds. If you need extra practice, do them all. All right. So this is the last scenario I have to show you. I can't just multiply by square root of 2. Because, I lied. Got to freak out. Give her that.
I'm not gonna freak out.
Who was that? Oh, that was like, no, that wasn't mean. I'm sorry. I didn't mean to be mean. It's coming to you.
I know what it is.
What?
4 over 10. Why?
All right.
Why?
So listen, I can't just multiply by the square root of 2 because if I multiply by square root of 2, the radicals aren't going to go away. You didn't get 2 papers, did you? Yes. So I have to multiply by what we call the conjugate. Y'all remember doing this? We did it with imaginary numbers. The conjugate is just where we change the sign in the middle. So I'm going to multiply the top and the bottom.
Why wouldn't it go away though?
Okay, so do it top and bottom though. What happens in the bottom if you do that? You get 6 square root 2 plus 2. Now I got a square root in the bottom still. Right. All right. Worth, I know that's not you. You know you need to do it. So not multiply. So if you look at your homework, when you get to 1, so like 13 and 14, you're just multiplying by the radical. But when you get to 15 and 17, those are conjugates.
Wait, we're only doing odds?
All right, only odds, only odds. So I'm going to multiply the top and the bottom by what? What's the conjugate?
6 minus square root 2.
6 minus square root 2. 6 minus. Remember doing this now? Only they had eyes in them. Right. Did you get both pages worth? Which? Okay. Pass that stack. Bless them and pass them back over. I saw you doing that. No, because then you won't get practice doing these kind. All right, I'm going to go ahead and multiply this. So I get. All right, look. On the top, if I distribute, I get 6 root 2, yes? Minus what? Minus 2. On the bottom, oh.
Oh, because it equals 4 and then the square root of that is 6.
Remember, square root of anything times the square root of the same anything just gives you the anything without a square root.
Like, actually did it, it'd be
He doesn't look
4,
like
and
that,
that's
not
square
sure.
root of 4.
Yes.
That's what happens.
Yes.
Okay, so.
Will you go come here? 34. 34. That's how many students I have in. I don't.
Isn't this like a fire now?
I don't make them sit on the floor though.
Oh yeah, dude, we do that.
I know. I don't make them sit on the floor. I acquire chairs for them all. Okay, now on the bottom, let's foil.
Wait, is always gonna cancel out or not?
On the bottom, yes.
All the time.
All the time if you do the conjugate. So 6 times 6 is
36
minus what? Minus what?
2. Because those cancel out.
6 square root 2. Oh, you're jumping ahead. You're skipping a little step. Okay. Plus 6 square root 2. I was like, Max, no. Okay. Root 2 times root 2 is 2. So minus 2. These middle two are canceling out as they should every time, right? Is anybody's brain blowing right now?
I have a question.
Yes. So you'll always foil conjugates. You'll always foil conjugates.
Those middle two always cancel out.
I'm sure you do, Sawyer. What? Yes. No, go ahead. I'm just picking. I was just picking. What's your question, Sawyer? But I will. Let me finish this. Okay. So I can simplify this a little bit, right?
Yes.
What's a simplify to? Divide by 2. 3 root 2. What's 2 divided by 2? Minus 1 over. I was waiting. Y'all get a sticker. What? All right. Sawyer. That's it. That's all I got. Do your work. Sawyer.
Miss McGee. Number 1.
All right, listen, if you're working, continue working. Sawyer has requested number 1 to be worked, so I shall work. Sawyer. I am probably going to look at this one and go, you know what? 270 divided by 3 is a nice whole even number. I would probably do that. As is 20 divided by 4, right? 5. What is 270 divided by 3? What do you think? How many times 3 go into 27? Where's that magic? 90. All right. Gracious, who were you talking to?
It was earlier to the power.
That's not nice. Look.
She's a pig.
She's a baby Jesus. I'm about to just give up. This is like rabid squirrels. Okay, Sawyer, 90. Perfect square. What can you divide by 90? 9 and 10. That's exactly right. Why do I use 9 and 10? Because 9. What is the square root, Max, of 9? 3. What? What is 5 times? That's fine. Did you multiply by square root of 3 in the beginning? Yes, that is fine. Yes. I divide 270 divided by 3 is 90. 20 divided, yep. Because it's in a fraction.
Wait, can you go over number 4?
Wait, what's number 2?
You really got us, Sawyer. You got us.
I don't want to do it.
What?
Since our exponents, you subtract them on a division.
That's exactly right.
You're lying.
I would put them both under the same radical.
Give me that.
So cubed root, put it all together. A10, B16, A5, B4, and subtract your exponents there. And then how many times does it go into? Whatever's left goes under the radical.